Hi, good afternoon, everyone. So P.5 algebraic expression. Last time we started talking about algebraic expression. We talked about polynomials, such that starting by monomial, binomial, trinomial. Then we move to the polynomial. I gave the definition for polynomial. Then we move to adding and subtracting polynomial. I gave some examples, and I moved to multiplying algebraic expression. Also, I gave some example for multiplying algebraic expression. The last thing we left there is the special product formula. Here is special product formulas. So first of all, we have to know if A, comma B, both of them are real numbers. Or sometimes they are not real, they are algebraic expression, like or algebraic expression. So first of all, we have to know, number one, a squared minus b squared, this is equal a minus b times a plus b. This is the first property. Second one is if I have a plus b square, this is equal the first term square, a square, plus 2 times the first term a times b, a times b, plus the second term square, b square. Okay, the third property is if I have a minus b everything square, this is equal the first term square minus 2 times a times b, first term times the second term, plus the second term square. So you have to know if in the middle is positive here, this must be positive here. If this is negative, this must be negative. Okay, so this is the only property we have to know. And the first one is called difference of square. A square minus b square is equal the first term minus the second term without the square times the first term plus the second term. The second one is always positive. I get the question here from Tao. No, sometimes if this in the second term here, if this one is positive, we have to know here it must be positive. If this is negative here, we have to know we should to write here negative. Okay. Example for that. Example, if I have 3x plus 5, everything square. So this is equal. Who will do it? Who will do this one? and tell me which property you have to use.
The second one.
The second one, exactly. So the first term is 3x, second term is b is 5. Okay, go ahead.
3x squared
3x
plus,
squared
yeah.
plus
You do 2 times 3x.
3x, okay,
Well, you gotta do
times
5. Yeah, times 5.
that's 5, okay,
And you do 5 squared.
5 squared. Thank you. So again, we have to distribute the exponent here inside the parentheses. So I get 3 squared is 9, and the x raised to the exponent 2 will be x squared plus 2 times 3 times 5. They give me 3. 2 times 3, they give me 6. 6 times 5 is 30 x plus the second one, this term 5 squared, they give me 25. Makes sense? Any question? So this is exactly the same like property number 2. The property said if I have a plus b, everything square, this is equal the first term square plus 2 times the first term times the second term plus the second term square. So my a here is 3x and my b is equal 5. And you plug inside the formula and you get the same like here, 9x squared plus 30x plus 25. Okay. Another example. Here, example 2. If I have 2x minus square root of y times 2x plus square root of y, who will do this one? Who will do this one? First of all, we don't have to multiply every term by the second, like all inside the parentheses by the second parentheses. We should to know which formula is equal or similar to this one. Look, we have here 2x minus the square root of y, and here we have 2x plus square root of y. So the first term is similar to the first term here. The second term here is positive, here is negative, sorry, and here we have positive, but they are similar. Square root of y, square root of y. But the difference, it's the sign. We have here negative, here we have positive. Which property is similar to this one from 1 to 3 here? Exactly, Amr. Same like the first one. We have a minus b times a plus b. And this is exactly like the first term square minus the second term square. Gadi, are you okay? You finished this slide? Okay. So going back to the example, we have the first term again. This here is exactly like the same like this one. So let me applying the formula. Yes, go ahead.
2x minus the square root of y squared.
Exactly, 2x squared minus square root of y, everything squared. And what is that equal? Matthew,
4x squared minus what?
for x squared minus what?
Y.
It should be the absolute value of y, because this is even exponent and the root here is 2 actually. And like I said last time, if it's even here and we have square, you have to put the absolute value of y. Should be the absolute value of y. So this is the answer for x squared minus the absolute value of y. Again, just reviewing, if I have something like this, square root of y to the power n, and here is n, and n equal, this is equal y if n is odd. If n is odd number. We know the odd number 1, 3, 5, 7, 9, 11. And also this is equal the absolute value of y if n is even. So n here is 2, is even. So the absolute value of y. Okay. No, it should be the absolute value of y. The absolute value of y, not y. Natasha. Should be the absolute value of y, because n here is even 2. If I have even number 2, 4, 6, 8, should be the absolute value. We wrote, yes, here is n, here is n. Same things here. We have 2, we have 2. And inside or outside, the same things. Doesn't matter. No, should be the same number. 2 and 2, 3 and 3, 4 and 4, 5 and 5, n and n. Okay, Abu Bakr? N and n, 5 and 5, 6 and 6. The same number exactly. Yes, but sometimes we have negative. If I'm multiplying something like Natasha, we have something like this. So this is equal square root of minus 3 times minus 3. And this is equal square root of 9. And this is equal 3. Okay? But I cannot say square root of minus 3 square. I cannot say this is equal minus 3. This is not equal. The answer is the absolute value of minus 3. It's equal 3. That's why we put the absolute value. Square root of minus 3, everything squared, is not equal 3, is not equal inside. Is equal the absolute value of minus 3 is 3 positive. No, we have to put it like this. 4x squared minus the absolute value of y, Natasha. Makes sense? Okay. But the negative is outside the radical. What do you mean, Matthew? You have a question? Where is the radical? Again, let me give you just a small review. We have to know the square root of minus 3, everything square, and here we have square is equal the absolute value of minus 3 square times square root of minus 3 square, and this is equal the absolute value of minus 3 times minus 3 square, and this is equal the absolute value of 9 square, and this is equal 3 positive. Or I can set square root of minus 3, everything square, because it's even number. This is equal the absolute value of inside the minus 3, and this is equal to the 3 positive. Makes sense what I said here down? Yes, Ryan. Only work for numbers are the same, 2 and 2, 4 and 4, 6 and 6. And the number must be even like 2, 4, 6, 8, 10, 12. But the odd, we don't have to put the absolute value. For the odd, we don't have to put the absolute value. Just we keep the numbers the same inside. If it's negative, be the answer negative. Positive will be positive. Any question?
Yeah, sorry to kind of keep. I'm just confused because isn't the radical on the outside of the parentheses? So it's radical y parentheses squared, not the square root of y squared. You know what I'm saying? Like the radical is on the outside, so that would be expand to radical y times radical y, which wouldn't that just be y? Whereas the absolute value thing would be the square root of y squared. Or am I just kind of getting this all wrong? I'm pretty confused.
Again, here, this is equal square root of y times the square root of y, right? And because it's even, this is equal the square root of y times y square. And this is equal square root of y square. And this is equal the absolute value of y. Always you have to know when this is even, the absolute value inside. When this is odd, just you put the number inside. Doesn't matter, it's negative or positive. The absolute value, we're looking for the positive only. Okay, so any other question for this one?
So is it always going to be the same number, or is it going to be different sometimes?
Which number do you mean?
Like the n.
The n? Yeah, sometimes for like most of the time for this different square will be square most of the time. But if this is like the third root, I can give you another example. If this is 3 will not be the same absolute value. The answer will be change.
So what would it be like? It would just be the y?
Only y?
Yeah.
If it's y only, just will be like y square. I give you another example. I give you example. Hold on 1 second. Example. If this is 2x minus y times 2x plus y. So by applying the first property, will be the first term square minus the second term square. And this is equal 4x squared minus y squared. That's it. I answer your question?
Like, I mean, I meant like for, like if one n is 3 and then one n is 2, is it the same rules gonna apply? Like, is it gonna be one y and then
Yes.
one?
Yeah, the same rule. The same rule. If we have the first term similar to the first term, second term similar to the second term is y and y, but the difference is here positive and here is negative. We have the same rule exactly.
Okay, I get it. Thank you.
Yeah, if I have the same term here, similar to the same term, second term is similar to the second term, the difference here is negative, here is positive. We're using the same property, the same rule. Yes, they canceling out each other, but we have to put the absolute value, Bilal. They cancel each other, but we have to use the absolute value. When you distribute the power of 2, does this radical sign gets canceled out? Yes, will be canceled out, but we have to put the absolute value because it's even number 2. Is the absolute value of y equal y? No, this is not correct. The absolute value of y, they're changing the negative to the positive. Everything negative changed to the positive. For example, I can set the absolute value of, suppose my y here, suppose my y equal minus 3. Is the absolute value of y equal y? This is no, not correct. Why? Because the absolute value of y equal the absolute value of minus 3, and this is equal 3. But y equal minus 3, and the minus 3, the 3 is not equal minus 3. Again, if my y equal minus 3, the absolute value is equal to y. No, this is not correct. Because the absolute value of y equal the absolute value of minus 3, this is equal 3. But y equal minus 3, and 3 not equal to minus 3. Okay, Natasha? Okay, let's go now to the next section is P6. Factoring, common factor. Would the minus sign stay? The minus, which minus would? Again, the absolute value changing the minus to the positive. The absolute value for any negative number is positive, this number. Okay? So the absolute value for minus 3, Natasha, this is equal to 3 positive. And y is minus 3. And give me 3 only. But the value of y is negative 3. So the 3 not equal to the minus 3. The absolute value again is the distance from the 0 to this number. So the distance should be positive. The absolute value of y is changing the negative to the positive. Any other questions? Okay, so now factoring a common factor. So we should to know if I have something like this, x squared minus 4, the factor for this one from high school is equal x minus the square root of the second term, 2, times x plus 2. So I should to know from this side, from here to this side, this is called factoring. This is factoring. And from the other side, from here to here, this is called expanding. So expanding and factoring. Okay, first things we have to know the common factor. Common factor. So I give you some example. So factor each of have 3x, number 1, 3x squared minus 6x. So I'm going to do this one. So to factor, what is the meaning of common factor? First of all, when you see something like this, we have to factor the first term and you should to factor the second term. So 3x squared means 3 times x minus the 6x means 6 times x. So the common factor, no, it's not 6x. I'm going to factor also the 6. So the 6 is 2 times 3 times x. Here, 3 times x times x. So the common factor, as we see here, the 3 and also the x. So I should write now, and also the x. And the 2 is not common factor between the two terms. So now I get 3, I worked outside, and I put the x also. The remaining here in the first term is x only, and the remaining here is 2 only, minus 2. This is what I mean of common factor. So factoring of this one is 3x, open parentheses, x minus 2. Example 2. Two x plus 4 2x squared plus 4x. Who will do this one? Who will do this one? How can I get the common factor?
Wouldn't you do 2 times x times x?
2 times x
And then
plus
2 times 2 times x. Or 4 times
exactly
x, but
2 times 2x. Okay, what is the common factor?
it would be 2x.
2 and x, 2 and x. So now I get here 2x outside. What's left here?
X plus 2.
X plus 2. Thank you. Any question for the first and second example? Okay, the third example is if I have 2x plus 4 times x minus 3 minus 5 times x minus 3. What is the common factor between the first term and the second term? Between this and this?
X minus 3.
X minus 3. This is correct. A common factor here is x minus 3. Between the first term and the second term is x minus 3. What's left from the first term? After I brought this outside the parentheses, what's left here?
2x plus 4.
Exactly, 2x plus 4. And what's left in the second one?
Negative or minus 5.
Minus 5. This is correct. So let me simplifying the answer. So I get now x minus 3. Here 2x plus 4 minus 5. What I get? Minus 1. And this is the final answer. How I get the minus 1 from this two term? 4 minus 5, they give me minus 1. Give me minus 1.
Are we supposed to expand it after?
Expand it?
Yeah.
No, that's it. This is factoring. We don't have to expand it. We should to factor it, going from this side to this side. If you need to expand it, just you multiply the two parentheses together. And we're going to get the same like here, same answer like here. Or similar, it's not exactly. Any question for this one? For common factor? Okay, now let's go to the factoring trinomial. We have another form of factoring called factoring trinomial. Okay. So we're going to factor a polynomial of the form to factor polynomial of the form x square plus bx plus c. So the factor of this one, x square plus bx plus c, this is equal, we should open two parentheses. Inside the parentheses, we have to put x here plus depending in the sign. So we have to get r and s. We have to get r and s by the chain and the error. So the r and s, we have to know r times s. This is equal this c. And we should to know also r plus s equal b. So we have to we have to factor the c, this number c, into two numbers, r and s, such that the multiplying of these two numbers, they give me c, and the sum of these two numbers should give me b. So I'm going to give example how we can use this idea. For example, factor x squared plus 7x plus 12. So what is the factor of 12? Give me two integers. The multiplying of these two integers, they give me 12.
3 and 4.
3 and 4, what else?
2 and 6.
2
and
times 6. 3 times 4. What else?
1 times 12.
1 times 12. What else? That's it, we don't have. 3 and 4, they give me 12. 2 times 6, they give me 12. 1 times 12, they give me 12. Now, what's the sum of 2 and 6?
8.
They give me 8. But the inside here is b. So this is not going to work. So this one, they will not work. For the second one, 3 times 4, they give me 12. And 3 plus 4, what they give?
7.
7. So this is correct. This is going to work. What about the third one? 1 plus 12, they give me 13. But in the middle is 7, it's not 13. Also, this one, they will not work. So the only one this work is this one, 3 and 4. So now I have to open two parentheses. This is equal. So to open two parentheses, I have to put here x and x. The first number is 3 plus 3. The second number is 4. Again, 3 times 4, they give me 12. And 3 plus 4, they give me 7. So this is the factor of x squared plus 7x plus 12. Make sense? Another example. X squared plus 6x plus 9. What is the factor? Can you, yeah. Can you go back for a second? Yes, okay. So again, I have x squared plus 6x plus 9. What is the factor of 9? What numbers, two integer number, if I multiply these two numbers, they give me 9?
3 times 3.
3 times 3. What else?
9 times 1.
9 times 1. What else? We have more?
That's it.
That's it. We don't have.
Mhm.
Now, 3 plus 3, they give me 6. And we have 6 in the middle. This is correct. For the second one, 9 plus 1, they give me 10. So this is not going to work. So we don't need it. So the only one we factor it is 3 and 3. So we have to open two parentheses. X and X plus we have 3 and 3. Or we can write it in different way. We can write this one as equal X plus 3 what to the power 2 square. This is correct, Amar. 3 times 3. Make sense? Another example. X squared minus X plus X minus 20. Again, what's the factor of 20?
2 times 10.
2 times 10.
5 times 4.
5 times 4.
1
No,
times
but hold on 1 second. It's minus 20. Minus 20. Again, 2 times minus 10, right?
Negative
Minus
4
20. Negative 4 times
times
what?
5.
Times 5. What else?
Negative 20 times 1.
Minus 20 times 4 times 1. What else? 5 times negative 4.
Negative
What
10
else?
times 1.
Negative 10 times 4 times 2.
Yeah, times 2.
Okay, let's try now these numbers. Minus 4 plus 5. Give me minus 1. Plus 1. And we have plus 1. Here, this is work. That's correct from the first time. But if we look into the second and third time, so here we have minus 20 plus 1, minus 20 plus 1, they give me minus 19. And in the middle, we have positive 1. This is not going to work. For the third one, we have 5 minus 4. And this is equal, I mean, like here, negative, here, positive. We have negative 5 plus 4. They give me minus 1. And the minus 1 not work. For this one, we have negative 10 plus 2. Give me not minus 8. And this is not going to work because in the middle we have positive 1. The only one work is the first one, minus 4 and 5 positive. So this is not going to work. And this is the same things here. So the only one work the first one. So this is equal, open two parentheses, have X and X. Here we have negative 4. And here we have positive 5. Again, plus 5 times negative 4, they give me negative 20. And 5 minus 4, they give me positive 1. Makes sense? Here I get question, which way do you prefer we write it? Which way you prefer we write it? What do you mean exactly for your question? Write what? For the question above. Ah, okay, as you like, it depends on the question. If the question asks you to write it for one parenthesis up raised to the square root, you have to write it like this, or you can write it like this. Doesn't matter. You can write it like this or this. Both of them correct. Okay, now we have special factoring formulas. Here we have special.
I'm gonna break that fucking.
So first one we have to know a square minus b square is equal the first one minus b second term times a plus b. So this is only for factoring. This is called difference of square. The difference of square. Second property said formula a plus b everything square. This is equal the first one square plus 2ab plus b square. This is called the perfect square. Third one is a minus b square is equal a square minus 2ab plus the second term square. Again, this is called the perfect square. Okay, this is like formulas we should to know. Before we use it for numbers, now we're going to use it for factoring. Example for this, by using this formulas, factor 4x squared minus 25. What does that equal? Who will help me? Which property we have? Which formula we should to use? Which formula from 1 to 3 we should use for factoring this one? Apply the formula. And also last Saleh, he said the same thing, the first property. Can you, Natasha, the same things? Who can applying the formula for this one?
We could do the square roots.
Okay. How you can do, you're applying this one to the first property here, first formula.
You could do the 4x squared, the square root of 4x squared is 2x.
Again, this is equal what? What I should to write? So let me simplify it more. So here I can said this is equal to x everything square. Why? Because I said before we can distribute the 2 inside the parentheses. I get 2 squared, they give me 4. And also distribute the 2 to the variable x, they give me x squared. Minus the 25, I can write it as 5 to the power 2. Now, this thing is similar to the first property exactly. Now we can apply the same things for the formula such that this is my a here. This is my a. And this is my b. Now easy to using the formula. Now we apply inside the formula, I get a is 2x minus b is minus 5 times a is 2x again plus b, they give me plus 5. Yes, this is correct. So 2x minus 5 times 2x plus 5. So first things, solve something like that. We have to simplify it, and we have to make it the same exact like the formula. Then we have to apply the a and the b, and then you have to apply the difference of square formula. A minus b times a plus b.
Why did you turn the 4x into like 4x squared to 2x squared?
Yes, because I need to applying the formula number 1. So I have here a everything to the power 2. So I can change this one here to the 2xy, because if I distribute the 2 inside the parentheses, I get 2 to the power 2, and this is equal to 4. And x to the power 2, they give me x squared. So actually 4 times x squared is equal to x everything to the power 2. Now, if I'm going to back to the formula here, I have a squared. So 2x, all this term is my a. All this term to the 2 times x is my a. And the same things here, b squared. So my b, everything inside this parentheses is my b. So now we're applying the formula. A minus b is 2x minus 5 times a plus b is 2x plus 5. That's why I changing or turning the 4x squared to 2x, everything inside the parentheses raised to the power 2. I need only one piece raised to the power 2.
Thank you.
You're welcome. Another example. Now this example, depending in the common factor, is 3x factor. So here, factor 3x squared plus 15 x to the power 3 minus 21 x squared. Who will do this one?
Yes, first you have to find the common factor between all three terms.
Yes, what's the common factor? Okay,
The common factor would be x to the
what is the
power
common
2.
factor?
3x to the power 2.
X to the, hold on 1 second. Here we have 4. It's not 4. We have 4 here. We have small mistake. So what's the common factor again? Is 3?
3x to the power 2.
X to the power 2. Yes, this is correct. 3x to the power 2. Why? because if we factoring this one is 3 times x times x times x times x 4 times. And this the same things. The 15 is 3 times 5 times x times x times x 3 times again. Here minus 21, this is equal 7 times 3 times x times x. So the common factor between the first term, the second term, the third term, as Amr said, is 3x squared. Now, what's left from the first term, Amr?
X to the power 2.
X to the power 2. That's correct. Plus, what's left from the second term?
5x.
5x. Correct. And the last one?
7x.
7.
Oh, just
Without-
7.
Yes, 7. So the final answer is 3x squared times x squared plus 5x minus 7. Now, can I factor inside this parentheses here inside? Here. Can I factor this one? Here I have, like I said before, factoring the trinomial. Here I have x squared plus 5x minus 7. Can I factor this one? Or it's factored already?
You can factor it because the 7 cannot, if you multiply two numbers that multiply by 7, you cannot add it to, and it will be equal to 5, so you cannot.
We cannot factor it. This is correct because if we're looking for two numbers, these two numbers are the multiplying is minus 7 and the sum of these two numbers is 5. I can't find these two numbers. So let me factor the minus 7, for example. What two numbers, if I multiplying together, they give me minus 7? Who will give me two numbers? The product of these two numbers, they give me minus 7. One and minus 7. So 1 times minus 7. What else?
Negative 1 times 7.
Negative 1 times 7. What else?
That's it.
That's it. That's it, exactly. So what's the summation of 1 and minus 7? 1 minus 7.
Negative 6.
Negative 6 is not the same like positive 5, the middle one. And what is the sum of minus 1 and 7?
6.
Is 6 positive and is not equal to the 5. So I cannot factor this inside the parentheses. So I keep the answer like this: 3x squared, open parentheses, x squared plus 5x minus 7. So this is not gonna work here. This one here, not work, and this not work. Any other question for this example? Any question? So by this example, we finish P.6 factoring, common factor. Now let's go to the P7 is the rational expression. Okay, so P7 rational expressions.
You gonna make my start.
So what is the meaning of rational expression? So the rational expression means if I have is a fraction of two polynomial. So I can say here rational expression is equal polynomial over polynomial. Who will remind me what is the meaning of polynomial? What is the meaning of polynomial from last class?
Two, the one that have two natural numbers.
It's like what you said again. What is the meaning of polynomial? Sum of monomials. This is correct, Matthew. Okay, what is the meaning of monomials, Matthew? Real numbers and variables. I mean one. Laila, she said, yes. Matthew said ax to the power k. Yes. K is, what's the k exactly? Which set the k belong to? Non-negative, exactly. This is correct. Not any number. I can't say k is negative. Or what about zero? Can I plug the zero inside the k instead of k? Could be zero, the k? Yes, could be. Yes, this is correct. Why? Because they give me number. And also the number is monomial. So the polynomial is also, I give the official formula for the polynomial. I said b of x, b of n of x, this is equal a n x to the power n. This is a plus a n minus 1 x to the n minus 1 plus dot 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 plus a1 x plus a0. This is the polynomial. Again, the n here is the degree of the polynomial. If the degree 5, so here should be 5. If the degree again is the highest power of the polynomial. Or I can say the polynomial is sum of monomial, and monomial is anything of the formula ax to the power k, such that k is non-negative integer number. So it could be 0, could be 1, 2, 3, 4 to positive infinity, but it could not be any negative number. Okay. So rational expression is anything of the form polynomial over polynomial. Polynomial over polynomial can be rational. So I'm going to give you example, and you should to decide which of this example are rational expression. So the example is, if I have 2x over x plus minus 1. Second one is y minus 2 over y square. Here, y square. So here I have 1 y square plus 4. And the last one is the square root of, I mean like x over the square root of x squared plus 1. Now, could be this one as rational expression. The first one, this is a rational expression. So to know this is a rational expression, you should to ask yourself, is the numerator and the denominator are polynomial? So if we look in here, 2x is a polynomial. This is correct. And x plus minus 1 is a polynomial too. So this is also correct. So polynomial over polynomial is called rational expression. So this is yes. This is yes is rational. So here I can say This is, yes, rational. This is a rational expression because polynomial over polynomial. For the second one, is it a rational expression? If yes, please tell me why. If no, also tell me why. Yes, why Matthew? Why this is a rational expression? Both numerator and denominator are polynomial. This is correct. If we look into the numerator here, I see y minus 2, and y minus 2 is a polynomial, is linear. If I plug here instead of y, so I can just, I take in this term y, instead of a is a1, I plug 1, and instead of x, I plug y, and here a0 is minus 2. So this is polynomial. For the denominator is x squared plus 4. Also, this is a polynomial. So I can say here, yes, this is a rational expression. Now, for the third one, is it a rational expression? Is this a rational expression? Is not. Layla, she said is not because of the root things. Who has another answer? Why, if this is rational expression, why, and if it's not, also why is not a rational expression? Does x a polynomial here in the numerator? Is the x here polynomial, the numerator only? I'm looking for the numerator. Is it a polynomial here? Yes, it's a monomial. This is correct. Yeah, this is correct. This is a monomial. So it's a polynomial. But down the denominator, this is a polynomial here, square root of x squared plus 1. No, this is not a polynomial. So I have now polynomial over not polynomial. So they will not give me a rational expression. So this is correct here. This is no, is not an a rational expression. Why? Because the denominator here is square root. Here is monomial x, but in the denominator is not a polynomial because square root of x squared plus 1 is not polynomial. The square root of x squared plus 1 is not a polynomial. So this is not a rational expression. So now we know, so after this example, we could know what's the rational expression and which of the fraction is not a rational expression. So we have to check polynomial over polynomial. Now the second things in this section, we have to know the domain of an algebraic expression. So now let's go to the domain of algebraic expression. here of algebraic expression. So a lot of question in web assign ask about the domain. So I'm going to starting talking about this part of this section step by step. So the domain, I'm going to give you the definition. What's the meaning of domain? So you have to know the domain is a set of real numbers which will make the expression defined. Is a set of real numbers that make the expression well defined. So I'm going to give you example to explain what does this definition mean. So suppose I have a table like this. Here the expression. And here I have the domain. First one is 1 over x. Second one is the square root of x. And here I have 1 over square root of x. Okay. So for solving this one, to ask yourself what is the meaning of what is the domain, you have to ask which set of numbers I can plug inside this expression such that they give me will be defined. So what numbers I can plug inside this expression and they keep the expression will define. So I start from the positive numbers. Can I plug any positive numbers here? Like 1, 2, 3, 4, 5, 6, 7, or any real positive numbers? Yes, I can plug. They will not give me any error. So it will be defined. 1 over 1, they will be good. 1 over 2, 1 over 3, 1 over 5. Any positive numbers I can plug inside this expression. So they will not give me any error. Can I plug negative numbers here? Like -1, -2, -3, -5, 1 over -2, 1 over -5 will be defined. I can plug any negative numbers inside this expression, like 1 over -5, 1 over -6. Yes, so Matthew said, yes, you can. Yeah, this is correct. If I plug any negative numbers, for example, 1 over -1, they give me -1, 1 over -5, they give me an expression. So it will keep me defined. They will not give any error if I plug any negative numbers. So what about if I plug the 0? 1 over 0.
It would be
Will be
undefined.
defined? Will be undefined. This is correct. So I can say, like Lyra said, I can plug all numbers, positive and negative, except the 0. If I plug the 0, it will give me undefined. So I can plug all positive numbers here, will be fine. I can plug all negative numbers here, they will give me answer. But if I plug the 0, will be undefined. So I can set here all real numbers except 0. But if I want to explain this mathematically, so I can set like this: x such that x not equal 0. I mean, for that, all numbers such that this number not equal 0, all real numbers except the 0. For the second one, who will do the second one? What numbers I can plug inside the radical?
Only even numbers.
Even numbers. Can I plug the positive numbers? All positive numbers can I plug inside this radical? Any positive, like 1, 2, 3, 4, 5. Can I plug? Matthew said yes. Natasha said yes. Who also said yes? Who said no? I can't plug negative numbers. Bilal said yes. So all of you said yes, and the answer yes, correct. So I can plug any positive number inside the radical, and they will keep the radical defined. What about 0? Can I plug 0? Yes, I can plug. The square root of 0 is 0. Square root of the fourth root of 0 also 0. Any root of 0, they give me 0. So the answer, I can plug the 0. They will not give me any error. Now, what about the minus? Can I plug any minus number inside this radical? No. Who said no? Who said yes? Can I plug negative inside the radical? Square root of 2? I mean square root of x? Can I plug negative inside the square root? I should to know, like I said last time in the previous class, because here I have even number. When I have even number, inside the radical must be positive. Must be positive. I said if I cannot plug any negative because I have even number. But if it's odd, I can plug any negative and any positive. But because this is even number, 2, 4, 6, 10, 12, 14, all even numbers, I cannot plug inside the radical negative numbers. So I can plug, so actually I can plug any positive numbers inside this radical. Also, I can plug the 0, but I cannot plug any negative numbers. So here I can set the domain of this one is x such that x is greater than or equal 0. So x is greater than or equal 0. I mean all positive numbers with the 0. All positive numbers with the 0. So this is the domain. Now down. It's similar to this one, but the problem here is the x squared, square root of x is in the denominator. So like I said before, because it's square root, I should to plug the all positive numbers and the 0. But here we have small problem is I cannot plug the 0 in the denominator. Exactly, Natasha. So I can plug any positive in the numbers without the 0 here. Why? Because 1 over 0, they will be undefined. So I can set the same like the domain for the second one, but without equal the 0. So I can set x such that all positive numbers except the 0 and the negative. So I can set x greater than 0 without the equal. So this is the domain. For like question for domain, you should to ask yourself, can I plug the 0? Can I plug the positive? Can I plug the negative? Which number, if I plug it, they give me error or issue. So you have to remove all numbers that make the expression has issue or problem or undefined. I give you another example. So example, find the domain for 2x squared plus 4x plus 2. What is the domain for this one? This is a polynomial. What's the domain for 2x squared plus 4x plus 2? Can I plug positive numbers?
Yes.
Okay, yes, yes. Who said no? If I plug positive, they will be undefined or undefined? I mean, like if I plug any positive numbers, they will keep this expression defined. Yes, this is correct. So if I plug any positive number, they will keep the expression well defined. They will not get any error or any issue. What about the 0? Can I plug the 0 inside this one? So 2 times 0 plus 4 times 0 plus 2. The answer is 2. Yeah. So Matthew said, yes, I can plug the 0. Will be defined, still defined. What about also the negatives? Can I plug the negatives here inside this expression? If I plug any negative numbers, will stay like defined? Yes, also, yes, this is correct. So I can set here, I can plug any real numbers, positive or negative or 0. So I can set here the domain is all real numbers. So all real numbers is the domain for this expression. Now let's go to the simplifying rational expression. After we know the idea of for how to find the domain, also in the website we have a lot of examples for finding the domain, more than these examples. So let me give you now this. Now let's go to the how to simplify rational expression. Give you the idea how to simplify the rational expression. Then we're starting for examples. Simplifying rational expression. Type. Okay. So to simplify the rational expression, first of all, we have to factor both of the domain and the numerator and the denominator. Then we have to use the property said So here I can say, first of all, we have to factor both of the numerator and the denominator. And we use the property said if I have A times B over B times C, I can cancel the C with the C. So this give me A over C or A over B. Can you go back for a second? Yes, sure. Jennifer. Okay. So we have to factor both of the numerator and the denominator, and we use this property. AC over BC, we can cancel the C with the C, and I get A over B. Example for this. If I have, for example, x squared minus 1 over x squared plus x minus 2. Who will start doing this one? How we can factor the numerator? So this is like the property here before the formula. X squared minus 1 is called the difference of square. Factor is here, is the difference, this one. A squared minus B squared, this is equal A minus B times A plus B, the difference of square. So x squared minus 1, this is equal what? No, I cannot cancel the x squared from both sides. This is not correct. Yes, Matthew, this is correct. So the factor, also again, here some students, they said you cancel the x squared with x squared. This is not correct. You cannot cancel x squared with x squared. This is not correct. So you have to factor the numerator, then you factor the denominator. So the factor of the numerator is x minus 1, because this is the difference of square, x minus 1 times x plus 1. And also the denominator, what is the factor for the denominator? I have to looking for two numbers. The product of these two numbers, they give me minus 2, and the sum of these two numbers, they give me positive 1. Yes, Natasha. X plus 2, x minus 1. Let me check. So the two numbers, like Natasha said, is plus 2 times negative 1. The sum is 2 minus 1. They give me positive 1. And this is correct. The product of 2 times minus 1, they give me minus 2. And the sum of these two numbers, they give me also a positive 1. So this is actually is work. So here, correct. So now the factor, I can factor it by two parentheses. I open two parentheses. The first parentheses is x minus 2, plus 2, and the second one x minus 1. Now we're going to use the property here, cancel the common factor. What's the common factor?
X minus 1.
X minus 1. This is can cancel by this one here, x minus 1 with x minus 1. Correct. Now the left from the fraction is x plus 1 is x plus 1 and x plus 2. And this is the simplifying the rational expression. Makes sense? Any question for this one? Would not you cancel out the x? I cannot cancel out the x. Because here we have multiplication here. Here we have, because we have multiplication, so I can cancel this parentheses with this parentheses. But I cannot cancel the x squared with x squared because I have here addition, here subtraction. But because we have multiplication between the two parentheses, so I can cancel this parentheses with this parentheses. Some students, they said, can I cancel the x with the x? No, this is not correct. I cannot cancel this x with this x. I cannot cancel this x with this x. This is wrong. Will not work.
So let's say you ask
Okay.
us for domain. Let's say you ask us from the domain of this expression. Would it be all
Okay.
numbers or natural numbers?
So the domain, first of all, I can plug any number in the numerator. So I can plug any positive, any negative, and the 0 will be fine. But here in the denominator, it cannot be 0. So I have to look for the 0 of this polynomial. The 0 of this polynomial is the -2. So I can plug all positive numbers. I can plug the 0, but I cannot plug the -2. Because if I plug here inside this one -2, they will give me 0 in the denominator. Again, -2 plus 2, they give me 0 in the denominator. And when you give me the 0 in the denominator, will be undefined. So I can set here the domain. The domain is all real numbers except the 2. X such that x not equal -2. I cannot plug the -2. I can plug all positive numbers in the numerator. The 0, the negative will be defined, no problem. But in the denominator down, I cannot plug only the numbers -2, because if I plug the -2, they will give me here in the denominator 0, and when you get 0 in the denominator will be undefined. But I can plug the 0, I can plug the positive, I can plug not all the negatives, I can plug all the negatives except the -2. So I can say the domain is x such that x not equal -2. I can plug all real numbers except the -2. Okay, another example for how to simplifying rational expression. Example is x minus 2 x minus 2 over x to the power x squared minus 4. Who will do this one? What is the factor of the numerator and the denominator? What is the factor for the numerator? X minus 2. Can I factor it more than this? Stay the same, exactly. So I keep it the same, x minus 2. I cannot do anything. For the denominator, what's the factoring? X squared minus 4. Exactly, the x plus 2 times x minus 2. Why? Because it's the difference of square. X minus 2 times x plus 1, plus 2. Now, what I can cancel from the numerator and denominator?
We can cancel the x minus 2.
Yes, I cancel this one with this. After I cancel this with this, here it's left the one, number 1 only, not 0. Some students, they said 0. This is not correct. So here left is 1. And here left is x plus 2. And that's it. This is the final answer. Any question? Again, what is the domain here? The problem is from the denominator. The denominator, I don't need it to be 0. So Natasha said all numbers except the minus 2. This is correct. All numbers except x equal minus 2. Okay. Do you have any question for this 2 examples? Okay, we're going to stop up to here today and have a great day. See you next Wednesday. Have a good day.
Have a nice